All right, so 10.6.1. An account into which or out of which a sequence of scheduled payments is made, and that's what we call an annuity. Notice you can either, what happens for most annuities, a regular annuity, there's all kinds, but a regular annuity, you put money in, and after a certain point, then you start taking a monthly salary out of it. That's the original setup. So that's what an annuity was for. Like a lot, my retirement from the feds is an annuity because I put in money to them, you know, over the span of my working for them, and now I get a monthly retirement.
Right.
So it's kind of an annuity. You've got to plan ahead. If you don't plan ahead, a type of annuity in which the goal is to save a specific amount of money in a specific amount of time. And I forget where the name comes from, but this is what's called a sinking fund. You ever heard that before?
Yeah.
Yeah? Okay. So that's, like some people go, I want to be a millionaire. If I save for 40 years, how much would I have to put in every month for 40 years to reach $1 million if I know I can get 4.5% compounded monthly? Then you can figure that out with a simple formula. All right? So that's what a sinking fund does. It gives you a chance to realize how much you have to invest on a regular basis to get a certain specific amount of money after a specific amount of time. All right, so here's the formula for a ordinary annuity. You can see it's a complicated formula, but remember I gave you the handout, and that formula right here this is what it turns into on the calculator. And we have all of our favorite letters. R, annual rate of interest. N, number of compoundings per year. T, number of years. And A, future value. The only thing now is that P becomes the principal that you put in on a regular basis. It's no longer a lump sum principal. It's rather a payment principal. So P now stands for payment, although it's the same thing. It's what you're investing presently. Although presently doesn't mean just one time. It means at each interval of compounding. So notice that if I just flip the fraction on the other side, except for the P, right? If I divide by this over this, I get the bottom formula, which we're going to talk about later. This is for a sinking fund. See, this is if I know what I want to accumulate, I know the rate and I know the time that I want to do it in and how often I compound, then this is what I have to payment I have to put in on a regular basis for those N periods per year. So if N was 12, it'd be a monthly payment. If N was 4, it'd be a quarterly payment, etc. So these are related, just like when we had the compound interest formula, there was the future value formula and the present value formula. So these are very similar in that respect. This one tells you how much you can have at the end of the period. This tells you how much you have to put in to get that amount. All right, so those two formulas are on that handout. Let's go ahead and use them. So here's what's going on here. Periodic deposit, so that's P. It pays $2,000 at the end of each year, so it's a yearly payment. It's 5.5% compounded annually. Usually the payment schedule and the compounding go hand in hand, at least for us academically. In real life, it wouldn't have to. You might put in monthly and they might compound quarterly, but you know, that's something you can work out with the bank or whatever. And then the time's 30 years. So N is 1, T is 30, P is 2,000, and R is 5.5%. So we put those in the formula. If you follow along, it's on the back of the, remember it's on the back of the calendar. So you would put P which is 2,000. Then double left parentheses. 1 plus R, which is 0.055. Now divided by 1, I'll go ahead and put it in there. We don't really need it, but that's N. And then caret NT, so that's 1 times 30, right? 30 years, once a year. And then minus 1. Okay, and then right parentheses, and then divided by R over N. So divided by parentheses 0.055 divided by 1. So I'm putting the 1 in there just so you can see that you don't really need it mathematically. So we would get close to 145,000 after 30 years. All right, so let's see if our answer is correct. $144,870.96. All right, so now the real question is, how much did we actually put in? What was our total principal? Well, that'd be 2,000 times 30, because we did it for 30 years. So it'd be 60 grand. So we more than 2.5, right? More than doubled it. 2.5 would have been 150,000, so a little bit less than 2.5, 240% growth or whatever you want to call it. All right, so that's a straight up future value for an annuity. Let's see, we'll do a couple of these. Use the ordinary annuity formula to determine the accumulated amount in an annuity of $90 is invested semi-annually for 30 years at 5%. So it's a different level of savings. This would only be $180 a year instead of 2,000. Percentage is probably pretty much the same. So once again, you put P, 90, double left parentheses, 1 plus R over N, 0.05. Now it's divided by 2 because it's semi-annually. Caret NT, 2 times 30, that's 60 half years, minus 1, right parentheses, divided by R, 0.05 divided by 2, R over N.
Well, watch your,
yeah, thanks. So we get $12,239.24. And the question is, how much did you actually put in? So 90 times 2 times 30, 5,400. So once again, more, just about the same result, 2.5 times. 2.5 times would have been 108.27 is 135. So a little bit less. That's good. A little bit less. Any questions so far? There's not a lot of problems. It's a short homework. The thing is, they're worth more points.
right.
Because there's fewer of them.
Yeah.
So make sure you get these.
Yeah.
Right? All right. $300 is invested for 25 years at 4.5% compounded monthly. Okay, so now N is 12, T is 25, P is 300. So we start with P, double left parentheses, 1 plus R over N. You notice how it's always the same, 1 plus R over N? Yeah. If you divide it by 12, caret NT, 12 times 25. So that's 300 months, minus 1, parentheses, divided by R, 0.045, divided by 12. $165,899.40. Hey, I'm doing good. I always want to know, well, how much did we really invest? So it's monthly. So it's 300 times 12 times 25. 90,000. Almost doubled. Not quite. Double would be 180,000, honestly. So. But you see, this is a scheme where you just put it in there and you just leave it and you don't touch it till the 25 years is up. So. kind of like a trust, I guess, in a way. All right, let's see, I think the next one, we're gonna go to a sinking fund. Yeah. Now we're gonna reverse the process, we're gonna go to a sinking fund. Just let me point out, if you look at the formulas on the sheet, this could all be in one parentheses. On the bottom, I need parentheses around the whole denominator. That's why you have the double parentheses, you'll see. All right, so here we want semi-annual payments with 8% interest are compounded semi-annually for 4 years to accumulate $23,000. So how much is the semi-annual payment? So we take, now I'm just going to use single parentheses. A, which is 23,000, that's how much we want, times R, which is 8%, excuse me, and it's compounded semi-annually, so divided by 2. So the whole numerator, I don't need parentheses except to delineate it as a, see, there's parentheses around the R over the N, but order of operations isn't violated if I have A times R divided by N. I don't need parentheses internally. And then I divide by double parentheses 1 plus R 0.08 divided by 2 caret N is 2 and T is 4, so it's just 4 years minus 1 parentheses, if I remembered correctly. So it's 2496, and you'll notice it says always round up. When you have a sinking fund, you always round up. So I'm going to go with 14 because there's a 0 after the 4. Now it may turn out to be 15. Let's see if we're right or not. I'm going to take a chance. 0.14. Yeah. If for any reason you think you got it right, see, if this had been a 144, I would have rounded up to 15. That's what it means, round up.
Right.
Because if I would have, you'll see, we'll try one where if I use the wrong one, if I don't round up correctly, I'll end up with like $22,990, $8.36. I'll be off by $1.50, and that means I didn't reach that, which contractually the contract would have been violated, and somebody could take you to court with $1.50, and plus your reputation would be ruined, etc. So that's why I have a little note here. I always round up. So anyway, for this one, it was okay. Let's see. So how much did they invest? That's times 8, right? Because so they invested 19,969 to make 23. So they got a little bit over $300 interest in 4 years. But see, it's not a lump sum. They put that amount in every 6 months. Okay. 14. So now weekly payments, 6.8% interest for 35 years, compounded weekly for 35 years. They want to accumulate 900,000. Okay, so once again, I do 900,000. A is 900,000 times R, which is 6.8%, so 0.068, and it's compounded weekly. So N would be what? 52. Yeah, compounded weekly. Now divided by double F parentheses, 1 plus R 0.068 divided by 52 parentheses. Caret N is 52, T is 35, minus 1 parentheses. $120 every week. Now, this one's easy to round up, $120.24. See, most of the time you're going to round up because of the roundup rule. Even if that were 23.3 or 23.2, I would have rounded it to 24. And how much did he actually, if you take 120.24 times 52 times 35, So 219,000 to make 900,000, but over 35 years.
Right.
That's 4.5. That's 400, almost 450% increase. Right?
Mm-hmm.
So if you got money that you don't need, if you got $120 a week that you don't need, and you can get somebody to give you that astronomical percentage rate.
Yeah.
So the idea, people say, well, why would they give you this situation? Well, they're taking your money and they're investing it. And they have to be really good stewards with that because they don't want to mess it up to where they can't meet your demands. Although they're only in trouble if everybody demands at the same time, right? It's an ongoing process. Somebody's demanding, somebody's putting in, et cetera, et cetera. So finances are a strange thing.
Yeah.
You know
Oh, yeah.
that. So this one was straight up. Let's see what the next one does. One of these is going to make it so that we have to. Okay, so this is $20 each month. Oh, okay, this is a regular annuity. I better read it. To save for retirement, a student invests $20 each month in an ordinary annuity with 3% compounded monthly. Determine the accumulated amount in the student's annuity after 35 years. Okay, so this, we go back to the annuity formula. So now we start with the double parentheses, and we got P. No, I'm sorry. We get first we put P, then we do the double parentheses. So P, the payment's $20, and then I do double parentheses 1 plus R over N, 3%, and he's doing it monthly, so that's divided by 12. Caret 35 years, so caret 12 times 35 minus 1 divided by R over N, which is 0.03 divided by 12. So $14,831.27. And how much did he actually save? 20 times 12 times 35, 8,400 to make 14,800. So if you just add a zero, make it 200, then it would be 84,000 to make 148,000, right? Because you can see right away, just multiply by 10. All right, 19. To save for graduate school, a student invests $11.40 semi-annually in an ordinary annuity with 9% interest compounded semi-annually. Determine the accumulated amount in the student's annuity after 15 years. So once again, we're back to a regular annuity. So it's 1140 1 plus R 0.09, and it was semi-annually, so divided by 2, caret 2 times 15, so minus 1 parentheses divided by R 0.09 divided by 2, semi-annually. So you would have 69,548.06. And he invested 1140 times 2 times 15. So this is more than double, 34 to 30, almost 70. 34.2 to 69.5, yeah, just about. I'm rounding. All right, number 23, I think, goes back to, yeah. Becky wants to be a millionaire.
Yay, Becky.
25 years. How much does she need to invest quarterly in a sinking fund paying 5% interest, compounded quarterly, to accumulate $1 million in 25 years? Okay, so take 1 million, that's 6 zeros, times R, 5%, divided by N, which was quarterly, divided by, double parentheses, 1 plus R, 0.05, divided by 4, caret, N's 4 times T's 25, minus 1 parentheses. $5,000 every quarter. It's like $20,000 a year, right?
Yeah.
Now, this one automatically rounds up to 28. I don't have to fudge it. I don't have to worry about it. So let's see how much she actually have to pony up. 74.28 times 4 times 25. 100 months. Or 100 quarters. $500,000.
Wow.
Puts in $500,000 to make $1 million.
Yeah.
Over 25 years. So while we're at it, let's say that we didn't round that off correctly. Let's say we used 5074.27. Here's what happens. You would use the ordinary annuity formula. With that as your payment, you put in 5074.27 instead of 28, and you see what happens. You take 1 plus 0.05 divided by 4, caret 4 times 25, minus 1 divided by 0.05 divided by 4. You see, I get $1.73 less than just by not. That's what happens. So technically, you didn't actually reach the contract of 1 million or
Right.
the goal, whatever it was. So that's why we always round up. This one was an automatic roundup, but this is one you have to be careful with because I never know the numbers you'll get. So if you would have got 5074.273164, I still would have rounded up to 28 because it always tells you that. See, it always tells you.
Yeah.
If this number is 5 or larger, you automatically do it. You don't even think twice.
Right.
Now you have to think twice. Does it matter? Well, you can see that there's a couple of zeros after that in the third and fourth decimal place. It won't really matter. All right. All right. So hang loose for 1 second. We have an example. I forgot to bring it.
I'm so sad. I think I'm gonna have to go completely online after this class.
Yeah.
Like I'm gonna go do the hybrid. Really going classes because of my job and it's like yeah. Last 2 days have been really rough for me.
Okay, we're going to do these together. Have it calculated. So Annie and Zena, a comparison. Annie invested right after college for 10 years. She was from age 25 to 35. She put $100 a month into an ordinary annuity that paid 5.5% interest rate compounded monthly. Okay, so that's part A, 9A. So that's the regular annuity formula. So P is 100. So we start there. P 100. Double left parentheses. Then 1 plus R over N. So I think ours are gonna be the same, 5.5% for both of them, and we're gonna do everything monthly, so we'll keep everything the same. And then, carrot, 10 years, so that's, 10 times 12, 100, I'm just gonna put 120, and then minus one, and then divided by R over N, so it's 0.055 divided by 12. So she'll have 15,950. I need you guys to, verify that I'm right. Because I don't have an answer key. I'm going with you. $15,950.76. What do you mean? For the exponent?
Right,
No.
okay, no, but there's a bunch of people in your part, that's why I was asking. After the carrot.
Yeah.
I'm just asking.
I would have put 10 times 12 in parentheses, but I didn't bother because I did the multiplication myself. This order of operations it's not effective. See, this takes place first.
Right.
The minus one happens last. I need you to get 15,950.76. I'm just going back from memory. It sounds right. I didn't want to spend all the time looking for my answer key.
Not what I got.
No? What did you get?
Well, okay, so I did put the parentheses in front of the 120 minus one. That's the only thing that I have different.
But you need parentheses around the whole 120.
Yeah, I do. It wasn't.
No, you don't.
Where?
You have, see, when you put parentheses, you got to put parentheses around the other side of the 120 because 120 is the exponent. What you have is the exponent is 120 minus 1. See, this minus 1 doesn't do anything until after this exponent.
Okay.
Yeah. So how much, while you're doing that, I'm going to see how much she invested. She invested 100 times 12 times 10. 12,000. So she made almost $4,000. Did you get it yet, Maria?
Yeah, did I do something wrong, or I got a totally different number?
All right, so I'll do it again. Look, the formula is P. So P is 100. That's how much she's putting in.
Right.
So 100, then double left parentheses, 1 plus R, 0.055, divided by N. N is 12 because it's every month, right? Mm-hmm. And then, this time I'll do it. Look, caret, parentheses, 10 times 12. And then minus 1, right parentheses, divided by 0.055 divided by 12, parentheses. So I got the same number again. Should be correct.
No, I got 17,554.
Really?
Yeah. Why am I doing wrong?
Let me see. Oh, it's 0.05 instead of 0.055.
Oh, okay.
Hit second enter and just enter a 5.
Okay.
You use 5.5 in the numerator, but only 5% in the denominator.
Yeah, I see that.
Any luck, Maria?
1595.07.
76.
Yeah.
All right. So we agree. So this is what she did. She saved for 10 years, and now she's going to take that money, that 15,000, and she's gonna put it into, just a regular savings account. She's gonna just get compound interest. In other words, she's not gonna put any more money in. She's gonna take that and let that grow at the same rate, compounded at the same period for 30 years. She wants to see how much that grows. So that, now we gotta go back to formula number 1, the very top. P, so now our P is 15,950.76, and then times the quantity 1 plus R, still 5.5%. We're keeping everything equivalence, so we don't, say, well, this interest rate was different than that one. And then it's caret NT. So caret, now N is 12, and now T is 35. At age 65, no, I'm sorry, not 35, 30, because from age 35 to age 65, that's 30 years, so 360 months. So she'll have 82,000, I want you to verify it, $742.78. Did you get that number? So remember, we just used the compound interest formula. We used the future value formula, P, parentheses 1 plus R over M, caret NT. Very straight up. Very first formula we use in okay? You got it?
Yeah, I got it.
Okay. So how much, that's question B. What about C? What's your out-of-pocket investment? I already answered that. How much did she actually take out of her pocket, put in? She put in $100 a month for 10 years. That's 12,000. All right, so 12,000 is part C. So her 12,000 became almost 83,000. That was her scheme. Okay. Now the other girl, Zena, went right out of high school at age 20. She invested $50 a month in the ordinary annuity with an interest rate of 5.5% compounded monthly, and she kept it up until age 65. So for 45 years, she put half the amount that the other gal did. All right, so we want to know how much her future value was. So we take the ordinary annuity formula. P is 50, double left parentheses, 1 plus R over N. It's the same rate, 0.055. It's the same monthly payment. And now caret NT. N is 12 and T was 45, right? 45 years? Yeah. All right. Minus 1, parentheses, divided by R over N. So 0.055 divided by 12. So R and N are the same for both scenarios. So she's going to have $117,978.66. And what's her total out of pocket? Well, she put $50 per month, so times 12, times 45 years. So she actually spent $27,000 out of pocket.
Oh, wow.
She spent 27 to make 118,000, essentially. So, who had more future value? Obviously, Zena. Yeah. Okay, but who do you think was the better investment?
Annie.
Annie? Okay, what's your reasoning?
Because she only had to do what she had to do until the age of 35. Dina had to wait till she was 65 to get that money.
Right, and she only put half as much per month, but she had to do it for
a longer amount of time.
Yeah, for 45 years instead of 10,
right.
Double. Well, if she would have doubled it, okay. The other thing is, you're hitting on the key ideas. Annie had more out-of-pocket money
Mhm.
to spend for other stuff.
Right.
And she ended up not too far behind, 83 versus 118. You could say that's quite a bit of difference, but she had the availability of that money. She used it to her advantage as she went along for whatever the kids needed or the family needed.
Right, exactly.
Yeah. So this is two schemes. You can see they're very simplistic, but you can see how this would work out. You could start using these formulas for yourself and say, well, okay, so I want to do this or I want to do that. What could happen, you know? And I like Annie's because she puts a lot of effort at the beginning, and then she finds a place that's secure enough to give her that 5.5% every month for 30 years, which she has the discipline to save the money, and then she has the discipline to leave it sit.
Right.
And the reason she can do that, as we said, because she now has more money out of pocket for those last, in her case, the last 30 years. Right. Yeah. Interesting, huh? Yeah. Okay. So I hope you get the idea.
Mhm.
All right, so before we finish up, any questions? All right, so we're done with homework 9. We're essentially done with the course, believe it or not.
I know already.
Yeah, we still have 2 classes though, but here's what I would propose that we meet online.
Okay.
So we can all get out of traffic, for one thing.
Mm-hmm.
Is that going to be okay?
Absolutely.
Okay, you don't have to come armed with questions, but if you do, I can answer them just like we do here. It's just be online.
Right.
We can we can start on tomorrow at 5 o'clock. I'll be online.
Okay.
And all you got to do is come and say, hi, I'm okay, have a good day, and then you're gone, and I'll mark you present.
Okay.
And we'll do the same thing on Thursday. By Thursday, you'll have some questions you might have over test 3.
Right.
Test 3 opens up Wednesday.
Okay.
Well, Tuesday midnight.
Mm-hmm.
So by Wednesday, you're ready to do test 3.
Okay.
Also, the post-test opens up on Wednesday. The final dates for the post-test are Sunday and for test 3. I'll give you all the rest of the week. But you can feel free when you're ready just to go ahead and do them. If after taking test 3 and the post-test, you still want to do test 1 or 2 again, let me know.
Okay.
I don't think you will, because your grades are sufficiently high enough. You'll be happy if you continue in that.
Unless I miserably flunk this and have no.
And all you got to do is maintain your present average, and you're going to be fine.
Yeah.
Okay, and then so we'll meet tomorrow and Thursday at 5 o'clock online. The only other thing left, I have to ask you to do the monthly survey.
That's what I was going to ask you. When do we do that?
Right now.
Can we do it now?
Yeah.
Okay.
Do you know where it is?
Downstairs in the library.
You can do it right there.
What?
Just open up the computer, the laptop. No, the desktop. Just go in as a guest. You can go down to the library if you want.
Yeah.
They're just supposed to keep me away from influence. All I can tell you is just be honest. Just give me some good feedback.
Dr. K is awesome.
Yeah.
There you go.
You'll never overtake the one guy about 20 years ago. He's gone.
He's gone.
Monthly survey. You see? And then just find MGF. Monthly survey. And just find next, and then just find MGF. Okay. I appreciate it, ladies. And yeah, just keep in touch with me about anything you want to change, or if you need extensions on anything. I'll be happy to meet you halfway.
Thank you very much.
You're welcome.
You want this back now?
If you don't need it.
Can I bring mine back to you? Yeah.
What you can do is you go down to where the academic office is.
Uh-huh.
I got a mailbox.
Okay.
Just ask Jane to slip it in my mailbox.
Okay, great. It's the registrar. Yeah. I was just-
Right across the hall, yeah. Technically, I'm not supposed to be here while you do those, but I'm not trying to influence you one way or the
I have no idea what you're talking
other.
about.
Okay. I better stop this.